My name is Zach, and today we're going to be talking about batteries. Batteries are used from flashlights to the calculator you mess around with in your math class when you're bored out of your mind. Recently, I was asked about how batteries worked. Despite having taken multiple electronics courses, all I could say was that batteries produce a voltage, and I could use a given voltage value to find other values in the circuit. This video is designed for you to actually understand how batteries work and not have piecemeal knowledge of batteries like I did. So enjoy, and don't forget to like, subscribe, and click on the notification button for more electronics videos. This video is broken down into 3 modules. Module 1, parts of a battery and how it operates. Module 2, general purpose of a battery and important characteristics. Module 3, popular batteries and their purpose. Let's begin. The first part of a battery we will be talking about is the plastic wrapping. The purpose of the plastic wrapping is not just to provide free advertising for battery companies, but also provide key characteristics for the engineer. In particular, it's important to keep track of the voltage rating and the amp hour rating. These characteristics will be discussed in detail in Module 2. The next part we'll be talking about is below the plastic wrapping, and that is the steel casing. So the steel casing provides 2 primary functions. The first is that it holds the internal components in place so they don't wiggle around. The second is that it protects the components from the atmosphere. Unless you're living in a perfectly sealed environment, the battery needs to be protected from the elements. Batteries convert chemical energy into electrical energy through chemical reactions. In order for chemical reactions to take place, 3 materials are required. The first material required is called a cathode. A cathode is a metal used in the reduction chemical reaction. More on this type of reaction later. The next material required for a chemical reaction to take place is called the anode. The anode is a metal used in the oxidation chemical reaction. More on this type of reaction later. Lastly, the electrolyte. Sandwiched in between the cathode and the anode is a liquid or paste used in both the oxidation and reduction chemical reactions. The first chemical reaction we will discuss in depth is called oxidation. Oxidation causes 2 or more particles to react so that the result is some combination of particles and free electrons. An example of this is shown on the slide where the green circle symbolizes a free electron. Now apply this reaction to the battery. The electrolyte and the anode perform an oxidation chemical reaction. When this happens, the reaction creates free electrons. Electrons have negative charge and want to go to areas of positive charge. In this case, the electrons want to go to the plus area of the battery. However, they cannot take a direct path to the plus because of an insulator that blocks their way inside the battery. So then, that leads to the question, how do electrons reach the positive side of the battery? They do this by traveling through a conductive material, such as a wire, that connects the negative end to the positive end. The diagram on the slide shows a path of electrons traveling through a wire from the negative part of the battery to the positive part of the battery. However, just having a circuit that consists of a wire and a battery is dangerous because there's no element within the circuit that will provide the resistance required to slow down the electron flow. Also, the flow of electrons is designed to activate electronic components such as light bulbs. Therefore, having a circuit without an electronic component is pretty useless. Once the electron reaches the positive end of a battery, it interacts with the cathode in a reduction chemical reaction. A reduction reaction is a chemical reaction where an electron interacts with a particle or particles, and the final result consists of particles that have absorbed the free electron. Then the particles created from this reaction interact with the electrolyte in the anode to create free electrons, thus continuing the battery cycle. So batteries are a voltage source. The definition of voltage, at least the one I learned in college, is that voltage is the difference in electric potential. But what does that actually mean? When I first heard this definition in college, I thought it was just useless technical jargon. However, a good way to explain voltage practically is through the following water tower diagram. Voltage can be explained as the pressure created from gravity acting on the water until it reaches the discharge point as shown on the diagram. The more water, the more voltage. The diameter of a hole represents the resistance of the circuit. If there is a small hole, less water can escape as there is greater resistance preventing it from leaving the tower. Then the flow of water leaving the tower represents the flow of electrons or current of the circuit. The other major battery characteristic is ampere hours. Amp hours is the amount of current a battery can produce in a circuit before it needs to be replaced or recharged. The battery has a limited amount of materials that can be used for chemical reactions. When this material is used up, no more chemical reactions can take place, and therefore no more electrons can be created. Here's an example on how amp hours work. A battery rated for 4 amp hours can produce 4 amps for 1 hour, 2 amps for 2 hours, or 8 amps for 1/2 hour. It can be difficult to find a battery that meets the exact voltage and ampere hour requirements that your circuit needs. You can work around this problem by altering the battery configuration by placing them in either a series or parallel configuration. When batteries are placed in series, the voltage becomes additive. For example, 2 batteries rated at 1.5 volts placed in series produce a total voltage equal to 3 volts. You don't need to worry about any changes to the battery's amp hour rating as it stays the same as though there was only one battery in the circuit. Now let's look at the example of a 9-volt battery. When I first examined the 9-volt battery, I thought it had the exact composition as a 1.5-volt battery, except that it had more material to perform chemical reactions with. However, when I looked inside a 9-volt battery, I was surprised to see it was just 6 1.5-volt batteries in series. The other configuration that batteries can be placed in is called the parallel configuration. In parallel, the amp hour rating becomes additive. An example of this is when 2 batteries rated at 5 amp hours are placed in parallel with each other. The total amp hours of the circuit becomes 10. The voltage rating, however, stays the same in this configuration as though there is only one battery in the circuit. So far, we've talked about batteries in series and we've talked about batteries in parallel. But what happens when we have a configuration of batteries in series and parallel? This can best be explained by the example on the slide. In this configuration, you have 2 batteries in series, another 2 batteries in series, and then those batteries are connected in parallel. To find the overall voltage and amp hour rating of this circuit, you can add the voltage values of the 2 batteries in series and the amp hour values of the 2 batteries in parallel. This gives you an overall voltage of 3 volts and an overall amp hour rating of 10 amp hours. Now on to Module 3 that discusses popular batteries and their purpose. As we discussed in Module 2 during the amp hour section, batteries have a limited amount of metal that can be used for chemical reactions. When the metal is used up, one of 2 things happen based on the battery type. The battery is either disposed of properly or it is recharged. Before we discuss various battery types, let's briefly talk about how the batteries are recharged. It's a pretty cool process, and the process is easy to explain now that you've gone through these modules. The charger induces a current going from the positive side of the battery to the negative side of the battery. By reversing the current, the chemical reactions used to create electron flow are reversed, thereby restoring the metal used for these reactions. Once the metal has been restored, the battery can then provide voltage to the circuit again. Now let's discuss common primary battery types. The first type we'll talk about is the alkaline battery. As someone born and raised in the United States, I thought it was pretty cool that 80% of manufactured batteries in the US were alkaline. I thought this was interesting because alkaline batteries can be used in so many different applications, such as CD players, electronic toys, flashlights, and radios. For those that weren't born in the Stone Ages, CD players were used to play music before iPods and your cell phone even existed. See below for a picture of alkaline batteries. The other primary battery type we'll be talking about is the lithium battery. Lithium batteries are used for long-life critical devices such as pacemakers and other implantable electronic devices. However, they are considerably more expensive than an alkaline battery. They can also come in button cells, as shown in the picture below. Now on to common rechargeable battery types. The first one we will be talking about is the lead-acid battery. This is your typical car battery. It is also used to store solar energy. What I mean is that it recharges by solar panels during the day and is discharged at night when solar energy is unavailable. The other rechargeable battery type you should know about is the lithium-ion battery. This is the go-to battery for cell phones, laptops, and digital cameras. It's also ideal for power tools such as sanders and saws. See below for a sample picture of a lithium-ion battery. Now let's talk about a topic that isn't necessarily related to how batteries work, but is important to know. That topic is battery recycling. It's not the one-time use batteries that get recycled, rather, it is rechargeable batteries. But why do rechargeable batteries need to be discarded? As I was researching this presentation, I was perplexed by this question. Shouldn't batteries be able to recharge indefinitely? The short answer is no. Rechargeable batteries lose their ability to recharge because during the recharge process discussed earlier in the module, imperfections and irregularities are formed. When enough of these are formed, the battery loses its ability to produce electrical energy. But why do they need to be recycled? Can't they just be thrown out? The answer is twofold. The first reason is that they use toxic materials such as cadmium or lead that could pollute the environment if placed in a landfill. The other reason is that they use uncommon metals that need to be recycled to prevent shortages of these valuable materials. One-time use batteries, such as alkaline batteries, are not typically recycled because the hazardous material that was used to make them has been removed from the design. And don't forget to like, subscribe, and click on the notification button for more electronics videos. I hope you all enjoyed the video, and if you have any questions or thoughts about the video, please leave a comment below.